This is the exercises on page 415. We're going to find the arcs that you see in the page, and remember the formula is theta equals the length of the arc divided by the radius. So for number 2, we would take, we know the theta is 1.36 and the radius, so we would multiply those two. 1.36 times the radius, 11.5, and we would find, 1.36 times the radius, which is 11.5, and we get 15.64 is S. For number 4, we would take 1.54, which is the theta in radians, times 2.87, and we would get the arc length is 4.42 3 sig digs. Number 26, we have to go the other way around. We would get 32.5 divided by 28.3, and we would get 1.15 radians. Number 8, 18.2 divided by 21.5, and we would get 0.847 radians. Number 10, we would take theta is pi over 12 and S is 88.1, so you'd take 88.1 divided by parentheses pi divided by 12, and we would get the radius is 336. 337 would be the radius. Number 12, we know 3.84 is the S. Divide by the number of radians, 2.08, and we get the radius is 1.85. 14, we know theta, so we would take S, 125, divided by theta, which is 5 times pi over 6, and we would get about 44.7 would be R. Find the latitude, number 16, of a city that is 1,265 miles from the equator. So we would take the 1,265, which isn't very far from the equator, divided by the radius, which is 3960, and we would find it's 0.319 radians. Okay, but remember, if you want to switch from radians to degrees, pi radians is 180, so you have to take that number of radians times 180 divided by pi. So times 180 divided by pi, and you get 18 degrees. Do we have to get just the latitude? So 18 degrees. I guess we could switch that to latitude 18 degrees, 18 minutes and 10 seconds north latitude. Well, it doesn't say north, it could be south too. So that's that assignment.